Hi guys, welcome back to building an Android application with Kotlin. My name is Tensor. Today we're going to be continuing building out our coin tracker application by building out the storage first. Then we'll look into building out our abstract activity. Then finally we will build out some of the parts of our dependency injection classes. I'm creating a package here called storage. Inside of it, I want to make a class called Delegated Preferences. For this class, Delegated Preferences, we want to have a generic type, and that will be for our default value. And we're also going to be passing through the context. So this will be the activity context. And then we'll be passing through a key, which will be a string. The basic concept behind this type of storage is essentially to create a small little file that sits on the device and works like a tiny little KeyValue storage or hash map. We have our key, which is the string, and if you remember, our model has all of these strings here, and these are going to be the keys that we're going to store our data with. Then of course the default value will be the actual data that we're storing. First we create a property called prefs, and this is a shared preference, and we want this to be lazy, so it will only be created when we need it. So we'll call context.getSharedPreferences, and then we'll send in context.getString. We'll send in our app name because that will be the name of this little file, and then we want this to be private, so we'll say context mode private. Then we want to create a getter and a setter function. We have a getter function called getValue. We pass in a reference, which can be in any type. And then we pass in a property, which is a kProperty type. This kProperty type allows us to essentially gain access to our key value pairs using reflection. Now I know I mentioned in the last tutorial that reflection in Android can be expensive. In this particular case, however, it isn't that expensive because we're just reading from a file rather than an API. With this kProperty type, we're using what's called star projection. This means that when t is an unknown type, we can safely read values from it. And it also means that there is nothing that you can write to kProperty in a safe way when t is unknown. So it's just a specific way of specifying that we can't write to this property unless we know the type, but we can read from this property if we don't know the type. Now we need to just create our find preferences and save preference functions. For find preferences, we pass in our key, which is a string, and our default type, which is type t. And then we run a with block on prefs. And inside of the closure, we create a value called result, and we set it equal to a when block that is checking on the default value. And with this when block, we're checking the type of the default value. If it's a boolean, we run get boolean. If it's an int, we run get int, and so on and so forth. And if it's none of these types, then we throw an illegal argument exception. Afterwards, we return the result and we cast it back as t. These get functions allow us to replace a value with a default value if we do not have a value. So say we're reading our key value store and we have a key but there's no assigned value to it, and say it's supposed to be an integer, then it will pass back the default integer type, which will be something like 0. This makes it so that we don't have to worry about getting null. For our save preference function, we pass in a key and a value, and again we run a with block, and this time we're going to put in prefs.edit. This will open up the file and edit it, and then we have our closure, which runs a when block on value. Again, we're checking the type, and instead of running get functions, we're running put functions. So we put in the boolean, we put in the integer, the long, the float, the string, or we throw an illegal argument exception. And then we call this apply function so that we actually apply the commits to the file. We also want to make a companion object called prefKey, and this will just have two values inside of it. One will be auto-update status, which will just literally be auto-update status as a string, and then we'll have auto-update duration, which will also be auto-update duration as a string. Okay, so this is our storage finished. Now let's build out our abstract activity. We will create a module called base, and inside of it we'll create a Kotlin class called BaseActivity. For our class, we want to extend AppCompactActivity, and this class, of course, is just the base Android class that supports any activity that uses support functions from Android. We want our BaseActivity class to be abstract, and then we're going to create a bunch of different things inside of it. We want to override the onCreate method because remember, this is basically just a skeleton for all of our other activities. OnCreate will call superOnCreate, then it will call setupLayout, initialize injection, and then onViewReady. These three functions are just protected abstract functions, and we'll extend them with our actual activities. Below these abstract functions, we want to create some actual functions. In particular, we're going to create a function called getTransparentBackgroundDialog. A dialog in Android is essentially just a dialog box that pops up and asks the user if they want to close the application or maybe change some preferences, things like that. So for this function, we'll pass back a dialog, and then we'll call a dialog on the context, and then we'll apply a closure to it. We want to make sure that the window that's popping up has no title. So we call requestWindowFeature, window.featureNoTitle. And then on our window, we'll call the let function with another closure. And this will allow us to iterate through all of the dialog boxes that are on the screen. Of course, we're only going to have one at a time though. We'll set the layout for this particular dialog box. The first argument in this method is the width, and we want this to be match parent. The second argument is the height, which we want to be wrap content. And then we want to call setBackgroundDrawableResource, and we're going to make it transparent. After that, we want to override one other function, and this is the onOptionsItem Selected function. This is a function that allows us to implement a menu inside of our application, and we just want to check to see if a user has clicked on Android R ID Home, and if a user hits the back button inside of this menu, then it will automatically take the user back to the home screen. Let's implement some of the classes that we're going to use to help us with the dependency injection. We'll create a package called DI, which stands for dependency injection. And then inside of it, we want to create a package called module and another package called component. In this app module class, we will specify that we want to take in the context as a private val, and we also want to annotate the class with module. Modules in Dagger are basically just the providers of the injection. So because this class has a provider inside of it, we have to specify it as a module. The provides annotation is what specifies that this function is going to be a provider. And then the singleton annotation makes sure that when we actually inject this function into something, it will not create new instances for each other injection afterward. So this function is pretty simple. We just want to provide the context. And the context, of course, is just the application context. Now we want to create another module called CryptoNetworkModule, and of course this is going to be a class, and we'll annotate it with module because it's a module. We want to create a companion object for this module. Inside of it we'll have a bunch of constants. We'll have a cache dir size of 30 megabytes, which will just be 30 times 1024 times 1024. Then we'll have a keep alive duration, which will be 30 times 1000. Which is essentially just 30,000 milliseconds or 30 seconds. And then we'll have another constant called max idle connections, which will be equal to 10. Then we want to create a bunch of providers inside of this module. The first one will be a singleton, and it will provide our JSON. Now JSON is basically the data structure that we're going to be providing to our application. So we return JSON builder, set field naming policy, we set the field naming policy to identity, and then we register type adapter. We pass in our class extension function with the date inside of it, and then the date type adapter, and then we create a new piece of JSON. Next, we want to create an injector for the OK HTTP logger interceptor. And this really isn't all that important for the debugging version of this application. If we were going to release it, we may want to have a higher logger level than what we currently have. What this does is it instantiates a new HTTP logger interceptor, and then we apply to it a closure where we set the level equal to log level none. And the log level function, which is right here, takes in the string none, and then it just basically pattern matches it against the strings that we have here. The HTTP logging interceptors allow us to essentially police our requests and responses, as well as log all of the requests and responses that go through our OK HTTP client. Now we want to create a provides cache function. This will take in the context and output the cache, and we'll return an instantiated cache object with context external cache dir, as well as the cache size of 30 megabytes. So this cache is not our storage, but rather it's a caching size that allows us to store some of the requests and responses if our application goes offline. This caching comes with OKHTTP. We also get connection pools with OKHTTP, and connection pooling allows us to specify how many idle connections we want. Because it's an asynchronous connection pool, we only want 10 idle connections. That was the constant that we defined up here. And then we only want it to keep alive a potentially idle connection for a maximum of 30 seconds. So that's our keep alive duration constant. And of course, we're using time unit of milliseconds, and that's why we have 30,000 for our keep alive duration. And essentially what this will do is the OKHTTP client will check to see if we have any idle connections. And then if we do, it will reuse them and redeploy them automatically. Next, we want to actually instantiate the OKHTTP3 client. We pass in our HTTP logging interceptor and our connection pool, and then we're going to be passing back our OKHTTP client. We set a value timeout equal to 20. This is so that we can time out for 20 seconds. And then we're going to return our client. We call builder on it. And then for our read, write, and connection timeout, we set these to 20 seconds. Then we add the interceptor and the connection pool, and then we build the actual client. OKHTTP is a modern, fast, and efficient HTTP client, and it supports things like HTTP2 and SPDY. It has connection pooling, gzipping, caching. It can recover from network problems, and it has sync and async calls, as well as redirects and retries. And it kind of goes hand in hand with Retrofit, which is the other library that we're using. We have a provider for Retrofit. This takes in our context, our OKHTTP client, and the JSON. And then Retrofit is called with the builder method. And then we add a converter factory to it. And because we're using JSON, we need to add the JSON converter factory. And we create JSON. And then we want to add a call adapter factory. And because we're using RxJava2, we need to use that. So RxJava2 call adapter factory.create. Our client will be our OKHTTP client. And then the base URL will be http API coinmarketcap.com. And then we're calling this build method to actually build out the Retrofit client. Retrofit itself is a type-safe REST adapter that makes it easy to do common networking tasks. It turns a REST API into a Java interface, and it uses annotations to describe HTTP requests. It takes care of URL manipulation, requesting, loading, caching, threading, and synchronization, and it also allows for sync and async calls. It also depends on OKHTTP. We can use various different data types to deserialize our data. In this case, we're using JSON. There are also several converters that we can add to Retrofit to support things like XML and JSON. Finally, we want to have a provides network utils function, a provides network service function, and a provides crypto network service. For provides network utils, we pass in the context, and then we're going to pass back the network utils. And we just call network utils and context inside of it. Then for the network service, because this is an interface, we pass in Retrofit and we're passing back network services. And then we call Retrofit create. We pass in our class extension function, and then we pass in the network services interface to create this provider. For crypto network service, we pass in our network services, and then we're going to pass back our crypto network service. And then we just instantiate it with the network services inside of it. Alright, so now that that's finished, we actually want to create what's called a component for our Dagger dependency injector. Our component will be called CryptoTracker Deps, and it will be an interface. To make this work, we have to annotate it with singleton, because we want it to be a single object rather than multiple instances. And then we need to annotate it with component. The two modules that we have are our app module and then our CryptoNetworkModule. This component is an interface that Dagger will use to generate code that will do the dependency injection for us. This interface has a single function in it currently, and it's called inject, and it takes in the main activity. This will allow us to inject all of the things that we have from our modules here and here into our main activity. Here's an actual example of us implementing this into our main activity. So we create a late initialization variable called CryptoDeps, and this will be the variable that we're injecting our dependencies into. Inside of our onCreate method, after the super onCreate call, we'll set our cryptodeps equal to dagger CryptoTrackerDeps.builder.appModule, and then we'll pass in the app module and the context, and then we'll build it, and then we'll call CryptoDeps.inject, and we'll pass this in here. Now notice that we're bringing in something called dagger CryptoTrackerDeps. This actually doesn't exist inside of our application. This is just generated code. So all you do is you take your interface name, which is CryptoTrackerDeps, and you add dagger to the front of it, and that will be the generated class. So why do we use dagger like this? Like, what exactly is it accomplishing for us, and what exactly is dependency injection? Dagger uses our modules and the providers inside of the modules to find basically instances where those providers are needed. So if there's a function that needs, for instance, the Retrofit client or the OK HTTP client inside of our main activity, the injector will automatically serve it up to that function. So Dagger basically creates what's called a dependency graph for us, and then it will automatically generate the needed code to hook up the appropriate dependencies with the objects that are looking for those dependencies. And of course, all of this isn't happening externally. So like normally if you want to bring in a dependency, you just import it like we're doing here. But with the injector, we're actually bringing it in from inside of the class. If you notice inside of our main activity, we actually have an error happening. And that's because I've run a build clean project, and this has destroyed all of the generated code that was created by Dagger. If we go ahead and run our build, however, it will actually generate this stuff, and then the errors will go away at runtime. So I'm actually building the application. I've opened up Genymotion here. We won't actually see anything on the surface of what's going on with our application, but obviously there's nothing here. But if you can look inside of the main activity now, this dagger CryptoTrackerDeps import actually works properly. Anyway guys, I hope you enjoyed this tutorial. If you did, feel free to subscribe and like. If you have any questions or comments, feel free to leave them in the box below. And if you dislike this video, then by all means downvote it as much as you like. Have a good day.